In this example, I'm going to demonstrate format manipulators. Here's a very simple program. I have two variables, x and y. You can see the values stored in there. I'm going to see out x is. It's going to display the value of the variable x, end down to the next line, and display y is the value of the variable y, and the program's going to end. Here's what it looks like. Okay, x is 123.456, y is 987.654. Okay, now I'm going to add some format manipulators. When you have any format manipulators, you need to add a new library in your program. So I'm going to include IO manip. That's the name of the library. Notice you can have more than one library up here. If you do, each library has to be on different lines, right, separate lines. Never any semicolons at the end of these preprocessor directives, and the order is not important. Now, most of the time, what programmers do is right before their cout statements, they'll put this line in here. Okay? And what fixed and show point do is they will ensure that the values that get displayed are, first of all, in a fixed notation. That means you won't see any values with an exponent in them, like e to the plus 02. The values that I'm using by default won't go into that exponential notation, but if you use values with more significant digits or larger values, they might. So you always want to use fixed. And show point, make sure that your decimal point displays. If you have a value like 4.0, it will only display 4 by default unless you have show point in there. So by putting this one line right prior to your cout statements where you display your results, it'll make sure that that's in effect for the rest of the program. Next, I'm going to demonstrate set precision. So I'm going to set the precision to 2, just because that was my choice. And set precision will set the number of decimal places for everything from this point on. Number of decimal places will be 2, right? 2 places after the decimal. Notice our values, 123.456 and 987.654. Let's run this program and see what happens now. Notice 2 places after the decimal. The first value, 123.4, was rounded up, right, because it was 456. And the second value, 0.65, was left alone because the value after the 5 is 4, so it's not going to round that value up. You can change the precision at any point in your program. I'm going to come down here. I'm going to set my precision to 1. And I'm going to run it again. So when x comes out, it should have a precision of 2, and then down here, this will change y to a precision of 1. And you'll see that's exactly what happened. Okay? Let's just see what happens when we change the precision to 0. Right? You'll see this. You get the decimal point, but you don't get the 0. Okay? And one last thing I'm going to do is I'm going to put an integer in here. Int z is assigned the value of 10. And at the end of my program, I'll display z as well. And let's see what happens. Now, keep in mind, z is an integer. Notice what happens with z. Set precision has no effect on integer. It only works with floating point values.